From here we'll go here. Okay, everything's on. Gain बढ़ा दिया and we are just a little bit more over here actually, even more because like people need to hear now. Still less ना. इसका चैनल तो फुल बढ़ा रखा है यार. Okay, whatever. So, hello guys. Today, well, this is the second part of Learn Rust with me, where you'll be learning Rust with me. Well, I mean literally, with me. With me, actually, yes. Because I'll be learning Rust too. And I'll just, explain any concepts that I have, using my prior experience. But like I am learning Rust, and because I have prior experience, then I'll actually try to understand the language. Maybe like I'll draw parallels to other languages, and well, we'll begin. Actually, there were some errors. I'll cover them. Not. I'll cover one of them actually. So in the last stream, I said that print ln was in Python, but there is no print ln in Python. There is just a print function. I looked it up later. I kind of, I was in the flow of it and I thought it's in Python, but then I remembered I never used print and then I looked it up. So there is no print function. None in Python actually. And so now we are going to actually cover, you know, we actually are going to go ahead in this. So if you want to read this part, there's basically nothing. There's just, a preamble. It's telling you that we'll cover all the programming concepts in here. Go to variables and mutability. So as mentioned in section storing values in variables section, by default variables are immutable. Okay, this is one of many nudges Rust gives you to write your code in a way that takes advantage of the safety and easy concurrency that Rust offers. However, you still have the option to make your variables mutable. Yes, okay. So variables are immutable. Basically, let x equal to 5. So if I assign this, so if x is equal to 5, I can print the value of x, but if I try to change the value over here, it will throw an error because it is immutable. Once you assign the value to the variable, you cannot change it. And I think in Java, actually there are, in Python I've actually discussed that tuple is a immutable data type or variable. Basically it's data type immutable. And then in Java you can make a variable immutable if you add the final keyword to it. So once it has final assigned to it, then you cannot change the value. So that is how immutable variables or data types work in your this other languages, basically in Java and in your Python. So see, basically what it told you. If you want to run it by yourself, we'll try it also. let me just, okay, and this goes, okay, not this one, okay, yep. So this was our last project, and well, I'll just use the same project. I'll it's better if I do. So what I'm going to do is actually, or should I just make a new project? Actually, we could try it here also. See, what I need to do is, if so, let this equal to 5. So since we already have an immutable variable right here, so let's say I want to change the value. Okay, I'll just go over here or anywhere, not even in the loop or outside. I'll just write secret number is equal to, I think, anything we will say 3. See, so this is what this is actually saying. Since there is no mut keyword over here, like this one, so it cannot be reassigned, basically. So secret number is 3, it cannot assign. Even if I run it. See? And okay, actually, wait. Okay. Still, so this was an error. I actually said last stream, do not forget the semicolon, and this thing happens also. Okay. Now, so if you see the error, if I could, how do I, oh, sorry, build output, how do I hide this? Don't pin it, but okay, I'll just push it in. So see, this is the error. It cannot assign twice to immutable variable. So this is simply the error. Otherwise, if I do, what guess is equal to, even if I, let's say, where is, if I just write, guess equal to, let's just say, right, hello. Okay. Okay, so if I just write, now we are actually going a bit. Okay, so what's the error? Invalid. Okay, oh, don't worry. What if I do this? So, okay, it's invalid, right? So I think, so this is because we already made an immutable variable over here. So it now takes, the guess is now an immutable variable. So what we are going to do instead, we'll do not clear guess is equal to fellow.toString. Okay, and then we do a, I'll copy this, and then so basically what I did here is I reassigned guest to this value, since this is a mutable string, and then I printed it before. If I run this, see, the word is fellow, and now I can input my number. So this is what this is. Okay. Sorry, I'm just spacing out a bit. And so this is what a mutable variable is. Sorry. If you Now we'll go down. Okay, this example shows how the compiler helps you find errors in your program. Compiler errors can be frustrating, but really they only mean your program isn't safely doing what you want it to do yet. They do not mean that you are not a good programmer. Okay, experienced crustaceans still get compiler errors. Okay. Yes. You received the error message cannot assign twice to immutable variable x because you tried to assign a second value to the immutable x variable. So this is what it did, which is what I did basically with the secret number example or the guest example below, which I did. So basically that's what it is, what I said, and but mutability can be very useful and can make code more convenient to write. Although variables are immutable by default, you can make them mutable by adding mut in front of the variable name as you did in chapter 2. Okay. Adding mut also conveys intent to future readers of the code by indicating the other parts of the code will be changing the variable's value. Okay, yes. So this is what it was. I think mutable. Like I'm still learning, but this is more live on stream, like just using my experience. So actually, yeah, because see, the intent now, if I look through the eyes of an experienced coder, okay. So the intent of the or a programmer, basically I am one. So what this function does, like what this code does, is so the intent of this variable, like the secret number, the intent is that I won't be changing it anytime soon. Once I assign it to the secret number, I won't be changing it anytime soon. Then over here, when I come to the guess this variable, since we wrote mut, which means a mutable variable, so this is an indication. I would know that this the value of this variable will be changed soon. Over here, basically, when I provide a string input, then over here, the guess variable is now, the intent is now for it to be immutable. So basically converting from a mutable string to an immutable integer. U32 means unsigned 32-bit. And normally it is in C, C++, so U32 does mean that. And So now this guess is immutable. You cannot change its value. So whatever you see will now, like, if I write guess is equal to this value, which I did actually, so it won't work basically. Now we are at constants. So, okay, so what he said, like, if I write MUT, which I obviously demonstrated, then you can change the value. And constants, like immutable variables, constants are values that are bound to a name and are not allowed to change. But there are a few differences between constants and variables. Okay, so immutable okay, yes, constants, and basically what I said, like a constant, final in Java, and you know. But there are a few differences between constants and variables. Now we'll look at the differences. First, you aren't allowed to use MUT with constants, okay? Constants aren't just immutable by default, they are always immutable, yes. That is true. You declare constants using the const keyword instead of the let keyword. And the type of the value must be annotated. Okay. We'll cover types and type annotations in the next section, data types, okay? Don't worry about the details right now. Just know that you must always annotate the types. What exactly is annotation? Okay, this is a weird moment for me. Okay. Oh, so basically you need a comment over there. Okay, I understood. So we'll just so the type of the value must be annotated in the sense that here. Okay, I understood. So basically what it's saying that I got confused in between, but a constant should always be in this form. So const sec num 32 is equal to okay, and then we put this. And okay, what is it saying? Such as sec num. Why? No. What if I just say secure num? Okay, it's still saying the same. Why? Oh, because is it the it should be in uppercase. Okay. So constants can be declared in any scope, including the global scope, which makes them useful for values that many parts of code need to know about. The last difference is that constants may be set only to a constant expression, not the result of a value that could only be computed at runtime. Okay. Here's an example of a constant declaration. Okay, so it is recommended to keep the constant, the constant name as an uppercase. Like, you have to keep the name in uppercase. So basically, it's telling me to, sorry. Like this. Something like this, okay. So here in let actually we skipped uh, the annotation. So this is the annotation, the thing you see here, U32. So in let we could actually skip it. In const we can't. So the last difference. So constants can be declared in any scope, including the global scope, uh, which makes them useful for values that many parts of code need to know about. So I can actually, sorry, just, yep, much better. So I can do this also. It's okay. And if I just do this, then we could. So instead of secret number, we'll just try this. And there you go. There you go. So now instead of secret num, I actually compared the inputted number to the constant. So you can do comparisons with a constant, but you cannot change its value ever. Like you cannot turn an immutable to a mutable or vice versa. If it is constant, like sorry, you cannot turn a constant into a mutable variable, and I think you actually, you can't actually turn a mutable to a constant. I think if that's the case, I do not know, but we'll try actually. If I want to know, I want to know now because I'm learning also. See, if I'm learning, so most of the things I'm saying is, how do I put it? It's actually no, as a person who's trying to learn something new, we'll try this. So let's see what happens. And what happened here? Expected MUT string, but MUT new 32. Oh. So that's what happens, huh? When you try to turn a mutable into. So basically, you can't turn a mutable into a constant. You can turn a mutable into an immutable, but not a constant. So, well, that's that. The constant's name, okay. So, last difference is that constant may only be set only to a constant expression, not the result of a value that could only be computed at runtime, okay. The constant's name, okay, so constant declaration we just covered, and so okay, Rust's naming convention for constants is to use all uppercase with underscores between the words, okay. Sorry, I'm just eating. The compiler is able to evaluate, sorry, The compiler is able to evaluate a limited set of operations at compile time, which lets us choose to write this value in a way that's easier to understand and verify. Okay, so see the Rust reference section on constant evaluation. Okay, constants are valid for the entire time a program runs within the scope in which they were declared. This property makes constants useful for values in your application domain that uh, multiple parts of the program might need to know about, such as the maximum number of points any player of a game is allowed to earn, or the speed of light. Okay, so they're nice. So if I put a constant here, like I put it here, so it's actually valid for the entire program now. Okay. Like except if I just call it above the constant, so it might not work. So if I just give an example over here, so the scope is always below after the declaration. So I can't print wait the secure number is, and I can't actually wait I can wait let me just test this. I don't think this is memory safe though. What the wait, this is the whole scope. How? So basically this means that if I declare constant in a block, normally see what happens if I declare a constant, or let's say a variable also, and let's say I want to print secret. See, so if I'm writing cannot find secret number because secret number has not been declared yet. So a variable cannot be called before its declaration or initialization. Basically, it's declaration if you know what I mean. So it cannot be like called, it cannot be accessed before its declaration. But a constant can, surprisingly. It's the first time I've seen this thing. So this is one of the main differences. Okay. This is actually good to know. Like if you try things out like this, like I put a variable instead of a constant, and the variable, it was giving a error, but now that I put the constant, actually redo. Okay, see, so if I did this, so the variable scope is actually below, like after the declaration. So if I write this instead, see how the error went away. Now it can find secret number and it will run. Obviously, it will print whatever number you have. And I could actually just press just do it. Okay. Since we already know what the secret number is. See, the secure number is 9. 9. What the Oh, because I'm already. Okay, okay, okay. So I put secure number here. So basically, this is what I'm trying to say. And see, the moment I put it above the variable, it will now give an error saying cannot find secret number in this scope because the scope is below. But wow, just forgive me if I'm going in circles, but this is actually a fun thing to discover. Um, okay. Naming hard-coded values used throughout your program as constants is useful in conveying the meaning of the value to future maintainers of the code. Okay. It also helps to have only one place in your code you would need to change if the hard-coded value needed to be updated in the future. Oh, okay. Yes, actually it's so basically if I write the constant this and I put a comment that this is the number. So if I have a constant value that is actually used everywhere and I need to update it, I'll just need to update it from here only. So if I say I want 100 instead of 98, there you go. You win. So now everything is working off just 100 only. And actually I'll just remove this. So this security num can be used in the whole main function, even above it, which is like wow. So and as you shadowing, okay. So what is shadowing? Okay, as you saw in the guessing name tutorial in chapter 2, you can declare a new variable with the same name as a previous variable. Yes, okay. Rustaceans say that the first variable is shadowed by the second, which means that the second variable is what the compiler will see when you use the name of the variable. Okay, we actually just saw it over here. So we saw it previously when I was trying to, change the value of guess, which I'll actually try to do now. Sorry, guess is equal to T3 and we put a colon. Now the error would be cannot assign a new value to an immutable variable because guess has now been replaced with an immutable integer type. That's it. So we can't use guess anymore. Semicolon always remember to put the semicolons. So this is what basically happened. This is what shadowing is. So earlier, if we could change the value of guess, we could actually change. So just to show you that small example again, guess is equal to and now wait, sorry, I'll just so if I run this, so this is valid but that isn't valid. So till here I can, it only would say let mud guess, and I don't know, it would throw a small warning or something. Nothing. So, but if I put the same thing down here, see how it became an error. Here it's okay. And even if I change the data type, let's say I put 32, it would still give an error. So this is what shadowing means. The moment it got assigned over here as an immutable variable, the compiler will take guess as an immutable variable only and as the integer type only. So which is what this is saying. In effect, the second variable overshadows the first, taking any uses of the variable name to itself until either it itself is shadowed or the scope ends. Okay. We can shadow a variable by using the same variable's name and repeating the use of the let keyword as follow. Okay. So let, okay. So I could just say so this would work sorry just okay. And let's say if I did so now that we did let, then we actually now we solved, like, this is what we did. So by using let, we were able to reassign a value, something like that. So since before we weren't able to actually do this, but if I do guess, so if I say it's now a string, okay, so we are done here. Okay, so if I just write let guess equal to 32 instead, there you go. So it still works. And what is no? So what's wrong actually over here? There is an error coming up. Type mismatch. Okay. Okay. Let's see. We do this. Oh, as mutable. Let's say we do this. Okay, so now and found U32. So obviously this will throw an error. I'll just undo all the changes. So this is how I learn. I basically play around with things and see what sticks and what doesn't. So if I haven't been talking too much, it's because I've been experimenting like this. So this is how you want to actually learn. If you saw the process, so this is how you actually want to do things. And I think, oh, I forgot to do one thing actually. My camera would actually be eating most of the screen. I'll just put it down here. And, or actually, I would put it up here for now. I think this is better. And we'll see. I'll just check from here. It's almost 11:30, and I think almost 45 minutes since we started, right? And okay. Okay, give me 2 seconds. Uh, YouTube. Sorry. So let me actually see. Okay. Uh, so I'll test the volume. Come on, bro. Okay, there we go. Okay, I'll just keep it running on the side over here. Actually, I'll continue with this. Okay, we wasted too much time, and well, we need to go ahead. Obviously, we won't be able to cover everything today, but the things we will be able to cover, we'll cover. Shadowing, as you saw in the okay, so we were doing shadowing only, and so it is showing me the examples which I actually tried out. Let x equal to 5. If x equal to 5, so it first assigns x 5 to x, then it would you know increase. So basically now I'm taking the current value of x, which is 5, then I'm adding 1 to it, and then I'm assigning it back to x. So this is x equal to x plus 1. And then you go into a code block. So this is a block of code. So this will if I put a if condition or something, then it would execute, or a loop. So it would execute differently. The behavior would be different from the rest of the code. Then it goes into the block, and now the value of x is 6. So then it would add 6. Sorry, it would add 2. Then it would be 8. So the x value of x in the inner scope is, wait, how is it 8? Oh, sorry, this is multiplication. Sorry, didn't see the thing, sorry. So it will multiply it by 2. So once it goes into a block, the scope of the assignment will stay within the block only. It won't come out of the block. So, which is good actually. This would be actually something to, how do I say, to adapt around, because this is a new concept for me. Like this, the block thingy. But no, sorry, it's not new. It's basically like you have a local variable inside of a block, as in C++. So you have a local x. So you can take this as the global x, global variable. Global variables can be used within the scope of the whole program. So, for example, if I see, I don't think I could use it over here, but we'll just try. Okay. If I say let x equals to 5 and this, so will it actually let me do it? Oh, क्या है? What's there? Let unexpected. Or if I say const x, how about, so constants can be declared outside of the program. So if I just sorry, so this constant is now a global variable. So I can use it in the main function. I can use it in any other function I declare apart from main. And so this is a global variable. But I can't do it. So constants can be global. It can be declared outside the program also, but not a variable. And there you go. See? It doesn't let you do it. Let is unexpected. So let can only be used in a function. This is one more. Variables can only be declared inside a function. This is one thing we learned over here. So a local variable. So let's say this is the secret number. The secret number I can use after the loop also, but so this is a local variable that is local to the main function, and not only the main function, the scope is actually below the declaration. Basically, it can be used only below the declaration. If I write secret number here, like outside the loop, I can write it outside the loop. But since this guess, so this guess is a local variable. The scope of guess is only within the loop block. You can't actually access this variable outside the loop. So for example, if I write okay, print ln, so instead of secret number, if I write guess, can't write it. See, it's red now. Cannot find value guess in this code because the scope of guess, so the area of access. So if you want to explain it in layman stuff, The scope of guest is just within the loop only. So this is scoping. So basically, what happened here is this x is now local. It's the value of x. So the value which is coming from, so this x is actually coming from above the global variable. It gets multiplied by 2 and it gets assigned to this x, which is now a local variable. So within this block, the value of x will now be 12, since it is 6 multiplied by 2. But once I go outside this block, the value will change back to 6, because this x was local to this block only. The value won't come outside. So that is how shadowing works. So shadowing will only work within a block. No, sorry, not will work only within a block, but this shadowing, so this value of 12 will only hold within the block. So the only shadowing which will have, so basically if I write this is basically if I write secret number, okay, I let this, and if I just write like is equal to let secret number, no, not this, but number x2, okay. And then if I write this, sorry, secret number, okay. And now if I copy this and I paste it outside the loop over here, so watch what happens now, okay. So I say my guess is you guess, okay, and you guess 32 too small. So now what will happen, it's 82, right? So what I'm going to do now, since I know it is 82 and it was by 2, okay, multiplied by 2, secret number by 2, 41 into 2 is 82, everybody knows. I'll just put 41 and now just watch what happens. Wait, 41 is too small. How? Oh, because the secure num. Okay, it doesn't, don't worry. I'll just put 98. It's done over here. So now watch what happens when I put 98. This was embarrassing. So when I put 98, wait, it's still too small. Oh, now it's 100. Sorry, I forgot. I really. Okay, now I'm super embarrassed. But there you go. You guessed 82 and you guessed 41. So the value of secret number got changed only for the loop. The moment X came out of the loop, the value now comes as 41. There you go. So this is what this example was telling us. Shadowing is different from marking a variable as mut because we'll get a compile time error if we accidentally try to reassign the variable without using the let keyword. Okay, yes. That is actually, I don't know what's happening outside. So I won't. This stream is already going a bit weird, according to me. So don't worry about that. So, and I think even I'm not feeling it today, but we'll still stream like. And the first difference was which we covered. So if I write let mut guess, and I could just write guess equal to another value. So mut will allow you to change, simply just write guess equal to some variable, and then you can just change it. But if you have an immutable variable, then you have to keep writing let in order to reassign the value. So this is one thing you have to keep in mind. And so the first, okay, the other sorry, we are just going up and down. By using let, we can perform a few transformations on a value, but have the variable be immutable after those transformations have been complete. Okay, yes. Nice. So this is how we transform it, and in a block. The other difference between MUT and shadowing is that because we are effectively creating a new variable, when we use the let keyword again, we can change the type of the value but reuse the same name, which is okay. Wow, which we actually did. Like if you want me to, do it. For example, say our program asks a user to show how many spaces they want between some text by inputting space characters. And then we want to store that input as a number. So basically, if I just write, okay, now I don't know how to comment out things, but we'll try something over here. Let what rndstr, no, not this, equal to the quick fox jumped the lazy dog. Sorry, the brown fox jumped over the lazy dog, and then okay, this is just a weird example. Let rnd, sorry, string equal to rnd string dot not trim. Okay, so what we are going to do, print ln string is, sorry, so we'll show this and control D. Oh, it does duplicate. Good thing. Okay. So what we have here as an example, I gave a string quick brown fox jumped over the lazy dog, and I am outputting the value over here. Okay, so I print the string now. Now, when I reassign the string as an integer, it will take the length of this string and it would show it here, which is what basically happened over here. Okay, so this is what it is saying. So we had R&D string as a string data type in one instance, and then in the other instance we are using it as an integer or a usize, whatever the usize data type is. We'll actually study it further, I think, in this chapter only. This one is still over, but yeah. And the other difference in this is, okay, I'll so I'll erase this. So this also. So if I just say this and guess is equal to 32, let's say. Okay. So now what it's going to show me is this error, expected string but found I32. So you can't change the value of guess with a mutable. Like you can't change the data type, but if I write let, then I can change the data type, which is what this is saying. Okay. Now we jump to data types, and I would only be covering this till data types for now. Or if it gets too late, then I won't be covering data types fully. We'll be streaming till 12:30 because I need to get some sleep. Actually, I am too tired. Uh, we'll see about that. And let me just check my volumes are fine. Everything's fine. And okay, so what we are going to do now is scalar types, integer types. Okay, so we are going to continue with data types. But before that, I need to take a small break. 2 minute break. Okay, we are back. I'm checking the camera for a while. Okay, we are back. And okay, so we are on data types, right? Every value in Rust is of a certain data type, which tells Rust what kind of data is being specified so it knows how to work with the data. We'll look at two data types, scalar and compound. Okay, so these are the two types of data types. Okay, two data type subs. We'll look at two data type subsets. Okay, scalar and compound. Keep in mind that Rust is a statically typed language, which means that it must know the types of all variables at the compile time. Okay, firmware updates available. UEFI DBX. Ah, what is this? Gnomes Control Center. Cancel. We'll do it later. Actually, we are on stream, so can't do it. Um, okay. Keep in mind that Rust is statically typed language, which means that it must know the type of all variables at compile time. The compiler can usually infer what type we want to use based on the value and how we use it in cases where many types are possible, such as when we converted a string to a numeric type using parse in the comparing the guess to the secret number section. In chapter 2, we must add a type annotation like this. Yes, we have to actually. So U32, if we don't add the U32 annotation shown in the preceding code, Rust will display the following error, which means the compiler needs more information from us to know which type we want to use. Okay. Type annotations needed. Help consider giving guess and explicit type. Okay. So if we don't give like okay. So when we are converting a string, so basically like here, so we are converting the guess string to a numeric type. And if I remove this annotation, so sorry, let's see if it runs. See? So this is what happens if I don't assign it a, you know, type. Now it will work. Scalar types, so you'll see different type annotations for other data types. A scalar type represents a single value. Okay, so say scalar means one value, which means a string or an integer. Uh, so Rust has four primary scalar types: integers, which we saw now, floating point numbers, booleans, and characters. Okay, so these are primary types. You may recognize these from other programming languages. Let's jump into how they work in Rust. Okay, we'll jump in. Integer types. An integer is a number without a fractional component, obviously. That is basically what an integer is in any programming languages, in most of them actually. We used one integer type in chapter 2, the U32 type. See, it is an integer. The type declaration indicates that the value it's associated with should be an unsigned integer, which is what I told you in the last stream. U32 means unsigned integer 32 bit. Signed integers typically start with 1 instead of u. Sorry. So it's I32. Signed means I32 and unsigned means U32. Sorry, U32 is unsigned and I32 is signed. So it just reversed it a bit, sorry, but we'll see. Table 3.1 shows the built-in integer types in Rust. We can use any of these variants to declare the type of an integer value. So, integer type, there are various integer types. So there is an 8-bit integer, there is a 16-bit integer, there is a 32-bit integer, there is a 64-bit integer, there is a 128-bit integer, and there is a arch integer. So I think the arch type will be explained below. We'll just look at the explanation below. So the higher the bit count, the more values, like the more range of values the variable can store or the integer variable can store. Each variant can be either assigned or unsigned or has an explicit size. Signed and unsigned refers to whether it's possible for the number to be negative. In other words, whether the number needs to have a sign with it signed, or whether it will only ever be positive and can therefore be represented without a sign, which is unsigned. Okay. It's like writing numbers on paper. When the sign matters, a number is shown with a plus sign or a minus sign. However, when it's safe to assume the number is positive, it's shown with no sign. Signed numbers are stored using 2's complements representation. So, okay, so this is actually, if you go by 2's complement, okay. So, for example, if you want to understand what 2's complement is, okay. So, like I wish I had a notepad, like a Wacom or something, but I'll only, I'll just try anything to explain what a two's complement representation is. So if I just access Kate or anything, okay. Just want to use a paint application. We'll just use LibreOffice. Yes, actually for now we don't need. Okay. No, I just want to draw. Is it possible to draw? Yes, it is. So if for example I have 10, okay. So how much is 10? It is 1 0. अरे यार what 0, then 1 0. Worst handwriting ever. Okay. So what are 2's complement representation? Now this is the representation of plus 10. If I just write this and array plus 10. Okay, just give me a sec. Oh. Okay. Okay. Okay, just give me 2 seconds. There we go. Okay. So this is plus 10. If I want to write this in the negative, okay. So minus 10. This is what happens when I don't have a vacuum or a proper paint application. I'll need to find one. So if I want to write minus 10, so in the 2's complement representation, this will be represented as 0. So you need to keep the values, the bits. You have to keep the bits like as the same until you encounter the first one. So this is one. Sorry, I am not good at doing. Now after this one comes, you flip now. So the 0 becomes 1 and the 1 becomes 0. So this is your minus 10. Or if you want to see it that way, you could also assume that this is plus 4. Okay. No, sorry, it's not plus 4, it is plus 6. It is plus 6. So this is plus 6. If you want to look at it that way also. Okay. And if we flip it like this, then we go minus 6. So this is also plausible. If I use this as plus 6 and then I flip this, it becomes minus 6. So this is the 2's complementary representation. You have to remember to start from right to left when you are doing this. So this was a small tangent. We won't be bothering with it, and I won't save because I need actually a better application, and I need a vacuum or a drawing pad, drawing tablet, whatever. And okay, I wasted too much time. Each variant can be either signed or unsigned, and has an explicit sign. Okay, no, we already covered this. Sorry. So we are here. Each signed variant can store numbers from minus 2 raised to the power n minus 1 to 2 raised to the power n minus 1 minus 1 inclusive, where n is the number of bits that variant uses. So an I8 can store numbers from this 2 raised to the power minus 2 raised to the power 7 to 2 raised to the power 7 minus 1, which is your minus 128 to 127. This. Unsigned variants can store numbers from 0 to 2 raised to the power n minus 1. So, storing numbers from 0, so which is 0 to 255 over here. Okay. So, signed means 128 to so if you have a 8-bit signed integer, so it will store minus 128 to 127, and if you have a signed 8-bit integer, you can store from 0 to 255. Okay. You can write integer literals in any forms shown in table 3.2. Okay. Note that the number literals that can be multiple numeric types allow a type suffix such as 57U8 to designate the type. Okay. So I can write, okay. Number literals can also use underscore as a visual separator to make the number easier to read, such as 1 underscore 000, which will have the same value if had specified 1000. Okay. I don't understand. We need an example for this. So how do you know which type of integer to use? If you are unsure, yours default are generally a good place to start. Integer types default to I32, which means that you have a range of how much is 2 raised to the power 32? We'll use a calculator over here. Since we know the formula, okay, and I'll just search for cal. We'll use kcalc, okay, which is too small, yeah. Uh, won't use kcalc. Okay, so we have 2, and where's the exponent? We'll go for an advanced. Okay, and if I could x to the power y. Okay, so 2 to the power, sorry, let me just clear this. So when we use an I32, the minimum would be minus 2 to the power 32. So this is our minimum value, and the maximum value in I32 is okay minus 1. This is the maximum value and this is the minimum value. So this is the maximum and this is the minimum. 4296, not the 4 but this. So this is a range. It's a huge range. So integer overflow. Let's say you have a variable of type U8 that can hold values between 0 and 255. If you try to change the variable to a value outside the range, such as 256, integer overflow will occur. Obviously, if you are trying to assign it 256, so it will throw an error, which can result in one of two behaviors. When you're compiling in debug mode, Rust includes checks for integer overflow that causes your program to panic at a runtime if this behavior occurs. Rust uses the term panicking when a program exits with an error. Okay, we'll discuss panics in more depth in the unrecoverable errors with panic in chapter 9. Okay. When you're compiling in release mode with the release flag, Rust does not include checks for integer overflow that cause panics. Instead, if overflow occurs, Rust performs two complements wrapping. Okay, so the thing we discussed. In short, values greater than the maximum values the type can hold wrap around to the minimum of the values the type can hold. Okay, so in this example, if he writes 256, then minus 256. No, sorry, 256 becomes 0 and 257 becomes okay. So once he writes so this is basically a mod function kind of thing. So basically it's 256 and once he writes 256 then it's 0. The program won't panic, but the variables will have a value that probably isn't what you were expecting it to have. Relying on integer overflows wrapping behavior is considered an error. Okay. To explicitly handle the possibility of overflow, you can use these families of methods provided by the standard library for primitive number types. Wrap in all modes with the wrapping method, such as wrapping add. Return the none value if there is an overflow with the checked methods. return the value and boolean indicating whether there was overflow with the overflowing methods. Okay, and saturate the values minimum and maximum values with the saturating methods. Okay, we'll look at this later. Okay, but so now we are at floating point types, and how much is left? There's a lot left. There's a lot left. So considering it's 12:16, I'll quickly cover this. Scalar, I think we'll do floating points. Rust also has two primitive types for floating point numbers, which are numbers with decimal points. Okay, Rust floating point types are F32 and F64. Okay, floating, so 32-bit floating point and 64-bit floating point in size respectively. The default is F64 because on modern CPUs it's roughly the same speed as F32 but is capable of more precision. Okay, all four floating point types are signed. Okay, and you can actually hold more values in floating point. Here's an example that shows floating point numbers in action. Okay, should I try this? Okay, and let okay. So floating point numbers are represented according to the IEEE 754 standard. Okay, so see, the default is now coming as F64 over here, while we actually declared F32. So now our numeric operations. Rust supports the basic mathematical operations you will expect from all the number types: addition, subtraction, multiplication, division, and remainder, which is the mod basically. So integer division truncates towards 0 to the nearest integer, obviously, because there is no point system decimal in integer, so you can't actually divide and expect a point value to come. So you can't do for example 3 by 2. So if I write y equal to 3 by 2 over here as integer, then the value will come as 0 because the 0.5 will be sorry, the value won't come as 0, it will come as 1 because the 0.5 will be truncated. 3 by 2 if you do 3 by 2. So that's the thing over there. The following code shows how do you use for each numeric operations in a let statement. Okay, so first example, let num equal to 5 plus 10. So the result here will be 15. Then he'll subtract let difference equal to 95.5 minus 4.3, which comes down to 91.2. Okay, then product is 4 by 30, which is 120. Division is 56.7 by 32.2, which, see, we have provided the decimal points, so the result will come in decimal only. So if I run this, no output, huh? Okay, so I can't modify. Okay, so there won't be any output because there is no print statement. Let truncated equal to minus 5.3. Minus 5 by 3. So see, these are both integers. So in normal cases, the result would actually be 1.6, and then the 6 would keep repeating on 1.1 minus 1.666666. So this is the uh, answer that should come, but because these both of them are marked as integers without a decimal point, the result would actually come as minus 1. So which is, you know, this is what it provided. And remainder means 43 by 5. So we'll get 3 as an answer in remainder. Each expression in these statements uses a mathematical operation and evaluates to a single value, which is then bound to a variable. Uh, Appendix B contains a list of all operations that Rust provides. Okay, the Boolean type. As in most programming languages, a Boolean type in Rust has two possible values. Um, True and false, obviously, because booleans only have true and false. And if you just give me a second over here. Okay. So there's true and false. Booleans are 1 byte in size because you only need two values to represent. False is represented by 0 and true is represented by 1. So that's why it only needs 1 byte. Okay. Using too much. Fuck it. So okay, the main way to use boolean values, sorry, boolean type in Rust is specified using bool. Okay, so let f bool equal to false and let t is equal to true. Okay, the main way to use boolean values is through conditionals such as if expression. We'll cover how if expressions work in Rust in the control flow section. Okay, the character type. The Rust's character type is the language's most primitive alphabetic type. Here are some examples of declaring char values. File name src main.rs. Okay, so we have let c equal to z, let z char equal to z. Okay, so let what? Wait, how is this possible? Okay, note that we can specify char literals with single quotes as opposed to string literals which use double quotes. Okay, Rust's char type is 4 bytes in size and represents a Unicode scalar value. Okay, which means it can represent a lot more than just ASCII, which is accented letters, Chinese, Japanese, and Korean characters, emoji, and zero with spaces are all valid char values in Rust. Unicode scalar values that from u plus 4 times equal to u plus d7ff and u plus triple zero to u plus 10 4 times f. Okay, I'm now a bit confused, but I'll actually test it. We'll test it over here. Don't worry about that. However, a character isn't really a concept in Unicode, so your human intuition of what a character is may not match up to what a char is in Rust. We'll discuss these topics in details in storing 8 encoded text with strings in chapter 8. Okay, so if you want me to try Unicode, okay, so we'll actually, is this you? It's using UTF-8, right? I think. So sorry, code scalar value. Well, we'll do this. Okay. So if I try, there you go. So we have a lot more Unicode emojis. And oh, okay, we have everything. So let's just say that I want to use this. So if I want this emoji, so U plus 1 F90. So let's try, okay? We'll say, give me a few seconds. Sorry, not X. Okay, we'll just use X for now. Oh, don't worry. U plus, so U plus 1 F94. 1 F94. Which is, I think, this one, this. So what is this saying? Oh. Okay, I think it did not understand. What now? Okay, just let me. So if I just do this, I want to try something out. How did, let me just try this, okay? Okay, so if I just copy and paste the beard thingy, so should it work? If I just, let's say I pasted it. Ah, nice. Now we run. See, Unicode is coming. Okay, we wasted too much time here. And we were here. Now we move on to compound types. And I think it is 12:31. So what I'm going to do right now is I'm going to close this stream. We'll continue tomorrow in the evening. So I'll actually do another. I'll do two streams tomorrow instead of one. So I didn't explain the situation. I actually came back from home. Uh, so I was thinking that I would actually rather stream here than go home. No, I did go home, but I came back today. I went on Saturday, and well, for now, I'll actually put a pause to this. I'm actually really tired, and it's actually late. Around, I don't want to stream for too long at a time, so we'll just close this stream because I'm going in circles and I'm tired. So we'll continue this stream tomorrow, and anything we have to do. Uh, well, we'll continue with this, and we'll actually cover the entire chapter 2. I'll cover it and we'll stream along. So tomorrow, basically, remember, we have to cover this. Not tomorrow, actually today. So today there will be two streams actually instead of one. Because then tomorrow I have to do some work. Uh, Tomorrow I won't be able to stream in the day. Today I will be, because like after I sleep and wake up, I'll be able to stream in the day. So no problems with that. And well, we'll close this stream for now. Thank you for watching.